Okay, so now we are going to get into model tuning and how we can tune this model. So just a really quick recap, we took the iris data set and we want to know what petal length is. We went through some data cleaning and then we trained a model on the on our data, and then from we got a um, that model was able to perform when we tested it, and we got a mean squared error of 0.0654. So what we're going to try to do is figure out if there's anything we can do to bring that error down. And the way that we're going to do that is we are going to make a function that will iterate through all the columns, and it's going to drop whatever columns that it finds that will help reduce the error. In regression analysis, sometimes you'll have variables that are highly correlated, or you'll have variables that don't need to be in there that negatively impact the accuracy of your model. And by dropping those variables, it can actually, or by dropping those variables features, you can actually help, that can help improve the accuracy of your model. This is going to be very, very code heavy. So please don't get too intimidated with this. Like I said, work through this assignment as best as you can. And if all you can really get to is this, that's completely fine. But for those of you who want to go another step further, let's get into it. So we're going to create a function. I'm going to call this function model tuner. And so this function is going to take in model train and x test. X train and x test, and then y train and y test. And I want to use the exact same training data that I use for this model up here, because if I use different training data, then I'm obviously going to get different results. So, and I don't want that to happen. I want to improve the accuracy of this model up here rather than doing than just resplitting the data and getting new results based on randomness. Maybe another way that I just thought of actually right now that could even be a more beneficial way to set up this function is to actually just take the previous model and put it in. Actually, actually, we're not going to be able to do that. Never mind. We're not going to be able to take the previous model and plug it in just because it's already trained on a certain number of features. Never mind. Yeah, this is the way we're going to have to set it up. So those are our parameters. We're going to add another parameter called drops and set that by default equal to none. What this will allow us to do is if we want to drop a function when putting it in the model tuner, we just put in an array into this, and it will allow us to drop whatever features we wanted to. Okay, so the first thing I'm going to do is I'm going to say if drops is not equal to none. That means that the user put something in drops. We are going to make x train equal to, so I forgot a colon, or yeah, a colon up there, and we're going to make this equal to x trains is equal to x trains dot drop, and then we are going to specify the columns as drops. Now, important to notice that we are just setting it equal to drops, so that means when we enter drops, we must enter it as an array, since we don't have it as an array here. Okay, I'm going to do this exact same thing now, but I'm going to do it for x train. Or I'm sorry, x test. Okay, so that will drop, and I'll drop whatever features we wanted to initially. And then first thing we want to do is we want to make a new variable called best feature. And this is going to be the best feature to get rid of. And right now we don't know what that is, so we're just going to say it's none. Now we're going to take model dot fit. We're going to make a model in here and fit it to the training data and to the Y train and the X train data. Then we'll go ahead and make our Y predict. Now I know we used actual or we used prediction and actual for our variable names. This is usually standard convention though, is instead of having a prediction and an actual, you have Y predict that you can compare with Y train. So I'm going to make Y predict equal to model dot predict, and I'm going to make it predict on our X testing data. This is all just like what we just did a couple moments ago. Now I'm going to make this variable called minimum error, and I want this variable to initially be sent, I want this variable to initially be set to the minimum error of the test of the Y test versus the Y predict. And so the reason why I'm doing this is I'm upfront setting up what our minimum error is, which should be 0. Which should be this number up here. And you know what? I'm actually going to, let's just return that right now before I keep moving on in this function because I know things are getting a little bit complicated. So if I run that, then I run this function, you can see that I get the exact same identical number that I get up here. So that's what this function is doing. It's basically we created an entire function that did just what we did up there, and it's returning what the error is. So our goal is we want to beat this number. We want to beat this number that we have. So why don't just to see how we are performing, I'm going to create a print line statement. I'm going to say old error, and I'm just going to make that equal to the initial minimum error. Okay. Now I'm going to, now what I want to do is I want to create a way that it can iterate through all the different features and then find out what feature is the best to drop. So I'm going to create a for loop down here. I'm going to call this I'm going to have this for loop for features in X train dot columns. We're going to create our own X train temp, which is just going to be equal to X train dot drop, and then we want to drop feature, then x-axis is equal to 1. I'm going to do the same thing but for x test. So what this loop is doing is it's going through all the different features in their training data and it's going to drop them one by one. So we just drop them. Then we're going to run another model fit, and we are going to take our X train temp, and we are going to then gauge it against our Y train, and we'll then make a new Y predict and equal that to model dot predict and then x test temp. And then we're going to make the error equal to the mean squares error of y tests to y predict. And then we're going to do this function. We're going to make an if statement. If the error that we get in the experiment of dropping this one feature is less than our minimum error that the model already had, then we are going to set our minimum error equal to this error. And we are also going to set our, we're also going to set our best feature equal to whatever that feature is. So this will run through the data set and then tell me what feature is best to drop. So if I then have a print line statement here that says new error, I'll print out the new minimum error. And then I'm going to make another statement here that says feature dropped. And I can have it tell me the feature or best feature that it dropped. Okay, hopefully that runs. Now if I run this again, you see we had our old error that was 0, 5. This was our old error that we have. It was 0.0565, where now we're able to drop the error down to 0.062. So we were able to drop the error by almost 2% if we get rid of sepal width. So you can see why making a function like this could be so useful when you're trying to improve the accuracy of your model, because it'll go through and figure out what feature is best to drop. I can run this again, and if I do, let's say drops is equal to, I'll plug in this feature right here. You can see that, let's see. Ooh, that is very close. But apparently it thinks if we drop this species, it should increase our error, or it should decrease our error. Oops, wonder why that happened. Maybe we didn't set something up in the function right. Let me get back to this. Okay, sorry about that. I figured out what the error was. So it's trying to concatenate these two together, but best feature has a none type in it, and none type is not a string. So I'm just going to cast this to be a string, and that should fix the problem. And okay, so it says if we drop these two features, that should give us the best minimum error. So we started off from being at a mean squared error of 0.065, and we brought it down to 0.62. And it's also interesting just to run all of this separate times to see what happens. Should probably get rid of this on different sets of data. For instance, up here, we got a mean squared errors of 8 with this particular slice of data. Um, so by dropping pedal width, that was able to go from 8 all the way down to 6. Wow, that was quite the improvement. So let's go drops equals pedal width. Let's see if our model can do better. Wow, that brought us down to 6.69 now. Let's see if we can bring that down any even further. Okay, so that seems like the lowest that we're going to be able to get. But in that situation, that was a pretty big improvement. We improved our model by almost about like 1.5% in accuracy. So I hope that gives you a good idea of just how to do model tuning, what the idea and concept behind model tuning is. Just want to reiterate, you do not need to do full model tuning. Um, you don't have to go through this completely if you want to get, you don't have to go through this section if you want to get credit for this assignment. Doing up all this up here is sufficient. However, if you do want to push yourself, I highly encourage you to try doing model tuning, and the extra credit is portion of this assignment will require model tuning.